I will give a very brief overview of the method that I have adopted to produce this spreadsheet model. The source data comes from the NHS secondary care medicines data, which is released monthly. So here's the original one, the data set that I used for all of the years going up to 2022. And then for some reason in 2023 they changed the site and they put they brought over the 2022 data and then put so the 2023 and the first month of 2024 into there. The data for January 2019 through to 2020 December 2022 was extracted in May and June 2023. The data for the whole of 2023 was extracted in February 2024. Data is initially released as provisional and then a year or so later is marked as finalised. And you can see the provisional ones here, finalised ones there. And it didn't actually say on this earlier year, it didn't really say whether it was provisional or finalised, but it's with this new site it's started to include that information. So finalised is the latest data is March 2022 actually, so it's a bit longer than a year in this case. I've not made any attempts to, I don't know, I've not looked to see whether for instance, these December 2022, this data and earlier is the same as that December 2022 and earlier. I presume because these are provisional, then they are the same data, but I've not yet confirmed that. A year's worth of monthly source data was imported into an Access database, which could then be used to generate the annual reports. So if I go to secondary care medicines data here, so open up 2023, so that's basically I imported the whole of a year's data, so every single drug that the NHS Hospital Trust prescribed for 2023, the monthly total is in here. This ODS code is the 3-digit code for each hospital trust, each unique code for the hospital trust. That's the drug, that's the code of the drug there, and this is the quantity of the tablets or capsules prescribed, and then over here on the left is the year followed by the month. So you've got going to 2023 through to 01 down to 2023 12 at the very bottom. So there's probably, I don't know, 600 megabytes or something of data there. So there's quite a few entries. I think several, 3.6 million, 3.7 million entries in that database for that year. So I'd basically import the monthly data into an Access database, which can then be used to generate annual reports showing the monthly number of tablets for different drugs prescribed by each hospital trust in England. These reports are then sorted into order of the 3-digit hospital trust codes. This is the ODS codes, and subtotaled for each hospital trust. So if I look at here, this is an example of what I did. So these are all of the drugs that I looked at, and for instance, looking at the ALK source data, and these are all of the ALK drugs in their various varieties. Alectinib, 150 milligram capsules, so all of those, and then I've put these subtotals in here. That's the subtotal for hospital code ROA, That's the subtotal for hospital code ROB, ROD, and so on. And then different tabs are the different 30 milligram brigatinib tablets, 90 milligram brigatinib tablets, 180 milligram, and so on. There's this strange one which is 180 and 90 milligram for some reason, but it's not really used much. Ceritinib, lorlatinib, 25 milligram, 100 milligram. So I've done that for all of those, and then you can see, and then the subtotals are input into the NHS Hospital Trust list. So I've gone here at the very end. There's this tab. So I found all of the, there was a web page which listed all of these hospital codes and what the name of the hospital trust was, and also the region that it applied to. And so I put all of the data, the annual totals for each drug into a column here, and so on. So I built that up, populated that, and then the next thing that I did was I started to use the standing data from one of the other tabs that I've set up here. So if I was to do 2024, I'd put all of those, alectinib, brigatinib, ceritinib, lorlatinib into those columns, and then I started to manipulate that, and I'd first of all change this into the order of this over here. So I would change, sorry, there's one other column here. I'd change, so first of all I would change, before I input the data, I would change it into the order of this 3-digit hospital code, so I would be able to fairly easily put the numbers in. It's a bit time consuming typing them all in, but yeah, it's fine, I could do it. And then I would order it into this particular order of East of England, London, Midlands, and so on. And then I would start to put some rows in, so there'd be 10 rows at the top, and then I could copy that in, and then I'll copy all of these across over here into that as well. So I'd copy that over there, and then I'd put insert 4 rows here, and then copy in that at the bottom, including all the formulae and everything, and do the same, another 4 rows down, and then basically over time, this, I would have put this into another tab, this NHS Hospital Trust list into another tab called ALK 2024, and then over time, by putting in that, copying in that data, that ALK 2024 would start to look like this ALK 2024 table. Now this table, the formulae convert the tablet numbers here into patient numbers so if we look here, East of England, the East of England Hospital Trusts in 2023 prescribed 116,690 alectinib tablets. Now up here, these are what I believe to be the standard doses for each tablet. Some of it is very easy, like brigatinib. You will know I take brigatinib. The highest dose of brigatinib is 180 milligrams. That's the standard dose. So anybody taking 180 milligram tablets will be getting just 1 tablet per day, 365 tablets per year. The same with lorlatinib. That's highest dose is 100 milligrams, and so 365 tablets a year. Alectinib is a bit trickier. The standard dose is 8 tablets per year, but some people take 6, and so even a few will take 4, possibly 4. I'm not sure it will go lower than that. But I've assumed as an average across the whole population that they would each take on average 7 per day. So many will take 8, some will take 6, and a few 4, but on average 7. And then I've divided the total tablets by that number up there in the orange, and then by 365 days, and then that's a rough estimate of the number of patients on average on that particular drug in that region. So you can just see there, and then I've done the same for the other drugs as well. I should say as well, with it becomes quite tricky for the small fractional drugs with brigatinib, and I've just had to make educated guesses with these. I don't ultimately know whether some people are taking 2 lots of 90 milligrams to make 100 milligram, or whether it's a half dose, so it's 1 tablet a day for these people, or whether it's a 90 plus a 30 to what's that, to make 120. It's just so this unfortunately is an educated guess for this. I'll talk a bit later in the study about sensitivity analysis, so I make a few changes. When I look at the population size later, I made a few changes for what I would think would be the upper limits and the lower limits of these to gauge what the upper limit and lower limit of the plausible population size will be. So brigatinib, I'm afraid, quite tricky. I'm with the 30 milligram tablets, I'm assuming that they're often with, there's often taken several tablets per day, because I think 30 on its own, a quarter dose, possibly isn't efficacious. I don't know, but I would think there'd be 2, and sometimes there'd be people taking 30 with a 90, I guess, and I don't know. It's Ceritinib isn't really used too much now, so I'm not particularly bothered too much. I'll just assume the standard 3. Lorlatinib, as I said, the 100 milligram is the maximum. 25 milligram is one of the fractional. Quite often people, from what I understand, take a 3/4 dose. Unfortunately, lorlatinib commonly has neurocognitive effects on it, so dose reductions are not uncommon. So I would think possibly there'd be a three tablets for 3/4 or 2 tablets for a half dose. I've even heard of people taking a quarter dose, 1 tablet for periods of time, but I don't really know how efficacious that is. So looking at that, we can get that for each region. So I can do the same. Over here, I looked at the population according to the Office of National Statistics for these 7 NHS England regions: East of England, London, Midlands, North Eastern Yorkshire, North West, South East, and North and South West. I've put some of these blue cells are error checking cells, so I'm basically checking that the totals agree to other totals, so I can try and pick up any obvious errors. I've also gone a bit lower in terms of this data is for the high resolution maps, so I've grouped together, say, the ones in Bedfordshire and Cambridgeshire and Essex and those, so I can get a sort of rough county level. So East of England can be, as I say, can be subdivided into, it's not quite a county level, but it's roughly and often is a county level. So that's 116,694 alectinib tablets is there, further subdivided down into those groups with patient numbers in each of those areas there. So I've done that right through. These numbers are just copied down from the numbers that I've input at the top. So this is the data that I input from the source data, and then that's copied down here. There's a light blue row here, and this is for the Clatterbridge NHS Foundation Trust. I'll do a section on this a bit later, but what I've done is I've changed the data for that hospital because unfortunately the NHS secondary care medicines data was for the Clatterbridge for reasons that I don't particularly know, is looks odd for Clatterbridge, and I think it's wrong. So I think it was fine in 2019, looked fine in 2019, looked fine as far as I can tell for 2020, and then in 2021 it started going wrong. So all I did was just I used the 2020 data. For 2022, again, use the 2022 data, and oddly for 2023, the data from this NHS secondary care medicines data was often negative. So again, I just used the 2020 numbers because that was the last reliable data that I had. You'd notice there was also a red cell here. That's for one of the Plymouth University Hospital, Plymouth. Again, there was a similar data issue for reasons that I don't understand. There was a dramatic change in the ordering of 100 milligram lorlatinib tablets for a number of months. It went from initially it was like one patient per month, so 30 100 milligram tablets per month, and then it went up to I think it was 900 in a month or something like that, so it was just went through the roof for a number of months, and then it went back down to where it was before. So I just stripped that data out. I don't know why that happened. I presume whether it might have been some stockpiling or something, but I've just assumed that it was erroneous and I've removed it. But I'll talk about that in more detail in another section. There was one other trust where I did a similar thing. It was one of the control drugs. I can't remember off the top of my head which one it was, but I adjusted the control drug data of one particular hospital trust for a similar reason, where it was showing what seemed to be implausibly high numbers for a period of time. So looking from that, and then I've got these over here. So for instance, looking at the southwest of England here, there's a total of 70.1 or an average, I should say, of 70.1 ALK patients according to my model in southwest England. Bear in mind that's just a central figure. There's a range of possible value, so it might be somewhere between 60 and 80 or something like that. The southwest of England has a population of 5.67 million according to the Office of National Statistics. I took that, I think, from the mid value from June 2020. So I've assumed that the population across the UK hasn't changed that much from 1999 to 2023. It would have changed inevitably, but for simplicity I've just kept the same population number, and then divide by so number of patients divided by the population gives me a prevalence per million. So in other words, there's on average 12.4 ALK patients in the southwest of England, and I've done that for all the different regions, and then I've done it all for those sub-regions as well there, so you can see looking at so the different regions of the Midlands here, for instance, and such. With that data, I've then been able to map it onto a mapping solution. So this is the Excel maps, Excel Bing maps that I can use within Excel. It's not perfect. Unfortunately, like here, I'm comparing what I call the broad southeast down here with the north up here. They have fairly similar population sizes. This is, I think, 24.4 million in the broad southeast, and this area is I think almost 26 million. So what I actually did was, so slightly different, they're fairly similar but not quite. So what I did here in the map data, no, sorry, here, where's it gone? Where's it gone? Oh no, sorry, yeah, I did adjust for, anyway, so I've calculated the prevalence at the very bottom here, the prevalence in the two regions. So here we are, here's the population size. So the north has 26.39 million population, and the broad southeast has 24.49. So the prevalence numbers here, so there's 11.1 per million in the north and 14.5 in the broad southeast. Southwest is just out on its own for the moment. So looking at the maps here, you can see 14.5 versus 11.1, 14.5, 11.1. And then the next map is broken down into the 7 NHS England regions. There's London there, the broad southeast there, east of England there, southwest down there, Midlands there, and then here there is northeastern Yorkshire, and then that bit there is the northwest. So I've put all of that data in there. Unfortunately, as I say earlier, my mapping solution isn't perfect, so I get these grid lines where I don't particularly want them, and but it is what it is, and that's the best I can do for the moment. And then the final map is the most detailed one. You should probably read this one with a bit of caution, because you get these ups and downs all over the place. Now, one problem that I found when I did this was that London always lights up as the highest prevalence. Now, it may well be the highest in London, I don't know. The trouble is, a lot of people, I know anecdotally myself, a lot of people travel from outside of London and get treated at London hospitals because there's a lot of specialist centres there. So you can't really look at London on its own, unfortunately. So that's partly why I got these two super regions, broad southeast versus the north. The broad southeast, I've chose it particularly to look at that, partly because they have similar populations, but also if pollution is an issue, there's more of it in this southeast area than there is in the north, and you can look at pollution maps that show that. So particularly for looking at EGFR, where Professor Swanton and Mariam Jamal Hanjani at TracerX have done the study that showed PM 2.5 pollution seems to be a factor with EGFR. I wanted to see whether I could replicate what they'd done on the EGFR maps. So and then I wanted to go further down to see whether there's interesting patterns at this NHS England regional level, bearing in mind you can't really do it with London. And then I wanted to go even lower. This most detailed one is just really a patchwork, often a patchwork. It's quite useful, I think, for looking at particular spikes and errors, possibly looking for particular errors in the data. I found a few instances where I've done something wrong and it's created a spike there, which was quite so that helped with that. I will say a couple of the error potential errors in where I've done this would be, first of all, when I've subtotaled these at the very bottom, I do make sure that I have actually my subtotals agree to the total of all of the tablets, so that's fine, and the total that goes into the spreadsheet, it also agrees to these totals at the bottom. Now, two particular errors can be possible, and I've found instances of these that I've corrected. I sometimes sum the wrong range, so for instance, I've occasionally done, instead of all the RYs are R's, I've done RYJ and RYR, so I get a bigger total here for RYR being all of those and that. It's there in a few places, probably not many places, but I wouldn't be surprised if it's there in one or two places. Another problem that I've sometimes done is I read out all of these. I used to put it, when I was starting populating this spreadsheet, I put it so I actually did this, and I'll do a sort here. This is how I did it. Sort, where are you? Sort, custom sort by F, column F, which is the hospital trust. So there I was then able to have this side by side, and then I could put ROA into this one, so 118 and so on, and then the next one was ROB, so that's 30. Now occasionally would have put the wrong total into the wrong cell just by human error. It won't have happened that often, but it will have happened because I've put thousands of numbers in. The effect of individual numbers isn't particularly high, I doubt. So in most cases, when I've looked at the I've done a where's it, the population, where's it gone? I've got a table here. ALK annual analysis, that's the one. So I've also done the annual totals for each of these trusts here and highlighted the top 10 trusts for each year in green, and the similar number, the similar trusts come up year to year of being, not surprisingly, being the most commonly prescribing hospital trust. So that is again something that can highlight problems if something strange comes up. Here's where I'm saying that I said earlier about the Clatterbridge, where I've just used the 2020 data onwards, and so that stayed at 28 patients. Maybe I should have increased that a bit more, because looking at the Christie, for instance, that's increased a bit over time. I don't know. I might change that in future variations, future updates for this. But it's not really going to. I don't think it's going to change things that much on that one. So basically that's it. I will also talk about the p-values as well. The maps. I've got these chi-square p-values, so I've compared the two different regions. I've done the broad southeast compared to the north, and also again I've compared the southwest of England. So these, in this case, it's two low, what should be low PM 2.5 pollution areas with one another. So basically this tries to look at how skewed is this data, how unusual would this be this sort of bias be, if it's very close, if the numbers are fairly close, then it's, you know, it's not, the p-value is going to be getting close to 1 or something. Below 0.05 is statistical significance, and then the lower the better, really. The more skewed it is, the lower it becomes. So if I've done this correctly, and bear in mind I'm not a medical statistician or any sort of statistician, but I've worked out, I think I'm doing it correctly. So these were the comparing the north with the broad southeast. These are the actual numbers of patients in those two regions. Now, as I said earlier, the north has a slightly higher population than the broad southeast, so I've normalized that north number, so divided by 26.39 million and multiplied it by 24.49 million, so that's a comparable number with the broad southeast. A total of just under 625 patients for those two regions. And then if it was an absolutely equal uniform distribution, you'd expect 312 in each region. So then I've done this chi-square formula, which compares the normalized population with the expected population and see how unusual that is, and I get a p-value there. And then I've just simplified that into a series of different groups. Is it below 0.0? If it's above 0.05, then I just say the absolute number, and then it's 0.05, 0.01, 0.001, less than 0.01, and then the most, and then less than, I think it's less than 0.0001, and then the final one, which I'm not seeing on here, is double chevron, so much less than 0.0001, and I leave it at that. So I don't see that on this one. I do on the EGFR maps and a few others, but so that's basically the method that I've used. I've got some I've done it for all of the different years of the data that I have. For ALK, EGFR, ROS1, some of my controls, I have 5 years of data. I've got the I summarized the patient numbers up in the right here, and I'm also able to change, I'm also able to discriminate different drugs by putting in, so if I put 9999 in, so for instance, if I wanted to, actually let's just do first line drugs, we take out ceritinib and lorlatinib, so copy 9999 across, and that screens ceritinib and lorlatinib out, and then that changes the maps, and you can see those have all gone down to 0. Ceritinib, lorlatinib have gone down to 0. So these are just the alectinib and brigatinib numbers. The p-values, the chi-square p-values, have also been dynamically changed as well, and these map patterns have changed for just those drugs. So if you want to see, for instance, now just lorlatinib on its own, so let's put 9999 in all the others. And so now that's just a lorlatinib map. There's 3.4 million in this region and 2.2 million in that region. The p-values have changed, and this patchwork over here on the right for the most prevalence in the different roughly county size regions has also changed. So that's basically, I think that's everything that I've done. Let's check my notes. So yeah, I think that's everything.